Hey everyone, welcome back to another episode of Simple Programmer Podcast, Simple Programmer YouTube channel, whichever way that you're consuming this content. I've got another interview for you today, and today I've got actually a friend of mine that you may know him from the Programmers podcast and from Marionette JS, if you've used that, and he's also been on Get Up and Code and done a lot of stuff. You might even be a subscriber of his Watch Me Code service. But today I've got Derick Bailey on, and Derick is going to be talking about messaging. I thought this is something that I think most software developers don't really understand that well, and don't understand when or to use it and what exactly it is. So Derick's really kind of the expert on this topic, so I thought it'd be cool to interview him and dissect his brain a bit on this topic. So welcome, Derick.
Thanks, John. It's great to be here and happy to share any knowledge I can about messaging. It's one of those things that I think a lot of people do use without really knowing that they're using it. And I think there's a lot of value in really making these ideas an explicit part of what you do in your code and in your architecture, instead of just allowing it to be there implicitly with some of the things that we use already.
Okay, yeah. So before we jump right into it, let's why don't you just give a quick intro, like your background and who you are, just so everyone.
Sure. So like you said, I am an entrepreneur and part of the Programmers podcast. I'm a software developer by trade, and I've been doing software development since professionally since the mid to late 90s, but writing code since the late 80s, really. So quite a number of years under my belt in terms of actually writing code. And then in the last few years, have gone independent and have become an entrepreneur of sorts with Watch Me Code and a few other products and services that I've done and phased out over the last few years. And in the process of doing all of this, I've worked a lot with these messaging patterns and have blogged a lot about these patterns over the years at my old blog at lostechies.com/Derick Bailey, and then at my current blog as well at derickbailey.com, where you can find links to pretty much everything I do, including all of my screencasts at Watch Me Code, all of my products and services that I have, podcast episodes that I've been on, and blog posts and my mailing list and everything else.
Awesome, cool. So let's jump right into asking about messaging, because I think there's a lot of confusion about messaging. I think
Right.
I think of that enterprise integration patterns book,
Right.
or the that and then it's like and everyone was like that's read that book, they're like BizTalk, that tells me how to use BizTalk.
Right. So yeah,
Right?
for those not watching the video, I'm holding up a copy of that book right here. This is a giant tome of a book. It's like ridiculously large. 600, let's see, 700. How many pages is that? Like, yeah, 680 some odd pages of material in there. And frankly, this is the book on messaging. Anybody that's done any serious work in messaging should have a copy of that book sitting on their desk. It's well worth it. I actually own 2 copies of it, one print and one ebook version of it, because I reference it that often. I need to be able to look at it physically and electronically sometimes. So getting back to what messaging is, there's a lot of ways to describe messaging, and probably the easiest way was something that I learned from Jimmy Bogard in an interview that I did with him, where he described messaging as going to McDonald's and placing your order and having your order handed to you. When you stand there in front of the register at McDonald's, you are relaying a message to the person behind the register. I want a Big Mac, a Coke, and fries. You want fries with that? Yes, I just said fries. You want to supersize that? Sure, why not? Okay, so they ring that up in the register. Well, that register sends various messages throughout the rest of their system, the system that is McDonald's. It sends a message over to the fry station, over to the drink station, over to the burger station, to all these different places that need to be informed of your order so that your order can be completed. But when you do that, you don't sit there and expect the person at the register to stop what they're doing and go put the fries in the fryer, go put the meat patties on the grill, go get cups out of the cup package and start filling a drink. You don't expect one person to do everything. There are different people in the restaurant that fulfill these different functions. And the restaurant has sent messages via electronic means, to the different stations to tell the individual workers what work they need to do. And once all of these things are done, once the fries are ready, once the burger is ready, once the drink is ready, there's probably another person still that is looking at a physical printout of your order on a ticket. They're probably going to tape it to your tray, and they're going to use that as the master reference for knowing when your order is complete. And so they'll go get the French fries that you need. They'll get the burger that you ordered. They'll get the drink that you wanted. They'll put it on this tray, and they'll hand it to you because your order is now complete. That right there is a real-world example of what messaging in software is. It is using that drink ticket or that French fry ticket or whatever ticket it is at the different stations to cause some action to take place, to have some work be done in order to fulfill some other purpose.
Okay, and so now with that example, I guess with any some of it is sequential, and some of it would be happening at the same time, right?
Yeah.
And so I guess probably the same thing in software, right? Is like some things, like I think a lot of times we think of everything as serially, or we think of it as happening in parallel, but the reality is that some parts, some process, like we can break things apart and make some of it sequential and some of it in parallel.
Right. Yeah. So in that restaurant example, again, the person that makes your burger and wraps it up doesn't walk out to the front and put it on the tray for you. They put it into a little chute and it slides down to the front, so the person that is assembling your order can put it on the tray for you. So these are things that happen in series and sequentially, chronologically, so that they have to happen in order. The order has to be placed, and then the message is sent to create the burger. The burger is created, and then the burger slides down that little chute. Well, sliding down that little chute out toward the front actually is a message in and of itself. It's a visual message in this case. It's not a printout or a ticket, but it is a message. It is an indication that the burger is ready. So there's another message there, a response essentially, for the next person to take that burger and put it on your tray. So there are a lot of things that can and do happen in a very serial manner, or not serial, but a very sequential manner inside of messaging processes, while the larger system as a whole is operating very much in parallel.
Okay, so now, so with that, I guess, like to kind of bring it to more of the concrete, like code example. Suppose I'm working in a system, in a fairly large code base, or I don't know, whatever code base, and how do I know when I need to bring messaging in or when it should be? I mean, obviously there's, from your description, there's messaging happening already in anything, but when do you formally create the channels, use a bus, use the type of things, patterns that you'd read about in the enterprise application integration patterns book?
So there's a number of indicators for that. Well, first of all, if you've ever built a web page that makes an AJAX request, you're already doing messaging. That AJAX request from the browser back to the server, that's a message. That's a request response pattern right there. It's just a really implicit form of that request response pattern, whereas the book, Enterprise Integration Patterns, talks about formalizing that and the various pieces that you need in order for that to be formalized and really be implemented outside of a piece of technology that has it built in, someplace where it's not implicitly built in. So one of the easiest places to look for where you want to put messaging in place initially are those chunks of code where, okay, there's this long running process And it happens when a user makes a request to the web server, and the user is sitting there waiting for a response. There's this spinner,
Right.
or there's this blank white page, or whatever it is, and the user is waiting for the server to complete some work and then send a response back to the user. That's a pretty good indication that you have a place for a message to be involved, not only in the browser requesting to the server, but on the back end as well. The server can offload that process, that long-running thing, whatever it is, into some background process so that the user can have an immediate response that really just says, your request was sent, we'll notify you when it's done.
Right.
And the easiest place to start with that is usually email. A lot of websites and a lot of web applications have a contact form, for example, where you fill out a form, you type in your question or your comment or whatever, and you hit submit, and that sends a message to the web server, and then the web server is going to format your name and your comment and a bunch of other information into an email, and then it's going to contact an SMTP server somewhere, and it's going to hope that that server is available. And if not, it's going to handle for the error condition of that server being down. And most likely, it's going to blow up in the user's face and say, sorry, we can't send your email. Well, why not? Well, okay, why not? Because you have inline code in your request handler that is making the direct connection to the SMTP server instead of allowing that to happen in the background. So if you inserted a message queue in place, you could have that email message, you could have it formatted, you could have all the information gathered up, but instead of making the direct connection to the SMTP server from your web server, from the web request handler, send a message across RabbitMQ and let some other code on the other side of RabbitMQ do the real work. And you get a lot of advantages there because now it doesn't matter if the SMTP server is down. It can be down for a few seconds, a few minutes, a few days, and it really doesn't matter. You've got that message sitting in RabbitMQ that says this work needs to be done. And if the SMTP server is down, well, the message gets put back into RabbitMQ and it waits. And it gets processed again. And well, the server's still down. Okay, go back into RabbitMQ and wait. Okay, it's being processed again until finally the message is actually processed appropriately because the SMTP server is available and the email can actually be sent. You know, this may take a matter of seconds, but it may take a matter of minutes if you have flaky network connectivity or if the server's down or whatever. But the user doesn't care. The user doesn't need to know that your SMTP server is down. All they want to know is that, hey, I submitted this request for contact and it was submitted. Okay, great. At some point, an email will be sent or some other mechanism of actually communicating this message to whoever will happen, and I don't need to worry about it anymore because the website told me that it was submitted and we're good to go.
Okay. So that, yeah, that when you describe it that way, it reminds me of, or I think of like when I call up like tech support, and or any kind of customer support, and I put in my request, and they're like, oh, okay, yeah, we'll issue you that refund. Just hold on the line while I do that, and then I always say, can you just do it? Like, do you need me on the line?
Right.
And they're like, no, just hold while I'll give you a confirmation number when I'm done. And I'm like, why not just asynchronously do this? Like, let me just hang up and you do it, and then you can send me an email or call me if there's a problem.
Exactly. Like, you've got my contact information because I'm a customer. I just want a refund here. Just tell me when it's done. I got more important things to do.
Okay, and then I can think of like I'm trying to think of like I guess MailChimp, when I remember when I ever tried to download a list of users, I was shocked to see that like I'm expecting to click download and get the list of users, but then they're like, oh, we'll send you an email, and then I look at my email and the email, so they're like asynchronously. I'm putting in there, which makes sense because I don't need to wait, because it could take them like 15 minutes to download a list of users, right? But instead they're like, okay, we'll just call you when we're done. Yeah.
Imagine this. Imagine going out to GitHub and clicking on the button for a new repository. And then when you click the OK button to actually create it, the web server itself is just chugging and chugging and chugging away with millions of requests a minute. in order to do all of these things in Git. There's no way that they're doing that. Not a chance. I know with certainty that they're not doing that. When you click that button to create a repository on GitHub, they're using a library called Rescue, which sits on top of Redis as their message queuing server. And they send a message over through Rescue and have some code on the back end that reads that message and creates the actual repository and then tells the system that the repository has been created. So when you hit the refresh button on your browser, if GitHub is having a slow day for some reason because they're overwhelmed or they have servers going down or whatever, well, you can be guaranteed that the repository will be created, but you don't know when the repository will be created. You could hit refresh over and over and over again and see that wonderful little fax machine sliding back and forth, making a photocopy the way that they show when a repository is being cloned or whatever it is. And that message will show up over and over again until the back-end system finally says, hey, I'm done. This repository is now there. And then the front-end system will say, okay, great. Now we can actually load the real data to show to the user.
That makes sense. I guess also too that with the advantage of it, that is that they don't have to, like, if you refresh your page over and over again, you're not going to like start the same process over, because you're just sending the message and they can detect the duplicate message and or the first one, maybe it sends 50 messages, but only the first one that actually succeeds, you know, the rest get ignored once one succeeded. Like there's a lot of more options, I think, than what you have if you don't have messaging, if you're just connected to the process.
Yeah, and what you just described there is an incredibly important concept, the idea of processing a message once and only once. I think the term for that is idempotence, and the general gist of that is that really you just process a message once. Processing the same thing multiple times will not alter anything in the system. It'll be the exact same thing as it was previously because it's idempotent. It's not going to modify the system more than once.
Yeah, and there's like a JavaScript library you can use that will, it's called Viagra, that will help you with the...
Yes, exactly.
So real quick, we'll get more into this, but I just wanted, you mentioned RabbitMQ, and I just wanted, just for someone who wasn't familiar with it, because with your description of the messaging, maybe if you can just give a quick description. We'll get into RabbitMQ more when we talk about some of the stuff that you're doing, but.
Sure, so as my phone is ringing in the background, RabbitMQ is a message broker and message queuing system, and what that really means is let me give you a little bit of background. There's two ways of doing messaging. There's kind of peer-to-peer, where one system knows about the other system and just talks to it directly. Perfectly legitimate. A lot of messaging systems are built that way. Sending an AJAX request, that's what you do. The AJAX request knows the web server to contact, so it just contacts it.
Right.
But there's also this man-in-the-middle configuration, which is a message broker. And a message broker allows you to have the front end and the back end, or multiple pieces of your system, however you have your system configured. You can completely separate these things so that they don't even know anything about the other systems that are involved. They don't even know if other systems are involved. Right. All they know about is the message broker in the middle. So with RabbitMQ, you get that message broker out of the box. You can publish a message to an exchange in RabbitMQ, and RabbitMQ's exchanges will do some pretty cool routing in order to make sure the message goes to the right place, the right queue, and then at some other time, maybe it's a second from now, maybe it's almost instantaneous, but at some point in time, code on the other end of that queue will pick up the message and do the actual work.
Okay, so you're saying that so that basically RabbitMQ is a message broker,
right? As
opposed to so with RabbitMQ, you don't need to know, the systems involved don't need to know about each other. Sort of like the McDonald's example that you said. Like it's like the person taking the order doesn't need to know, hey Bob, make a burger. Yeah. It just goes into the system, and it doesn't matter if it's Bob or Jane or Carol. they just pick up the ticket and they make a burger.
Exactly. And sometimes the person that takes the order has to go into the back and make the burger, but it really doesn't matter. I mean, that may be the case because the only other person that's working at the moment happens to be busy doing something else, handling another customer or whatever the case is. So it provides a lot of flexibility and a lot of options, and including the ability to just not know or not care how the work actually gets done. You just know that it's going to get done because it went across the queue.
Okay, that makes sense. So, so if someone is looking at their how do they know when they need to go to? It sounds like, I mean, because correct me if I'm wrong, but pretty much every application is going to have messaging, like any complex application. But really, when we're talking about messaging, I guess most of the time we're really talking about message broker type of systems,
right?
Where that's when we actually kind of formally implement messaging, even if we do it in our own code, right? Mm-hmm. So what stage do you pull in the big guns, so to speak?
Anytime you have work that needs to coordinate different pieces of your application, and this applies across the board, not just to backend systems. We can talk about this in web development, in Ember.js, Backbone.js, Angular, whatever. If you're dealing with multiple pieces of a screen, you have a menu on one side and you have the main content, and then you have a header with navigation at the top, and you need to have all of these pieces of the application coordinate between each other, but you don't want them to talk directly to each other because that would create a very tightly coupled system. We can use messaging right there in your browser, not communicating back and forth with the server, but just talking between the pieces that are already on the screen running in JavaScript. There's a library called Postal.js, which is a phenomenal messaging library for in-memory messaging. It is a message broker. If you're doing Backbone.js and using Marionette.js, Marionette has these patterns baked into it as well. There's the Marionette Wrecker library, and then more generally, the Backbone Radio library is, again, a message broker that allows you to have that decoupled man in the middle to facilitate communication between all of these different places on the screen and in the application.
I see. Okay. So whenever you implement messaging, then you're definitely, I mean, you're going to it's a decoupling type of thing when you enter a message broker. So you're going to decouple your application. I didn't realize so much. Like I think a lot of people are familiar with maybe like in-service bus and mass transit and kind of the bigger
huge architectural things on the back end. Yeah, those are definitely popular and worth looking at if you're doing .NET. And service bus and mass transit are great service bus implementations for the back end code. But it applies across the board to Windows applications, web applications, in JavaScript, mobile devices, whatever the case may be.
Okay, so anywhere where you might want to decouple things and have different components that don't need to know about each other.
Yeah, so, and actually Android phones are a great example of that. I've got an Android phone here. And if you've ever done any Android development, which I'm pretty sure you have, John, you've probably dealt with the idea of an intent.
Exactly.
The intent to do something. Well, that intent is just another name for a messaging pattern, which is essentially a command or a request response scenario. It kind of varies depending on the specific intent that you're dealing with. But the intent in Android development is a wrapper and a specifically named form of messaging between different applications in the system, in the phone.
Okay, awesome. Okay, yeah, now I was actually able to. I did a Pluralsight course on actually using RabbitMQ to actually do .NET to Java interoperability, which kind of proves the point of what you're saying about the independent. And I found RabbitMQ to be pretty robust and really fast. I know a lot of what you've been doing lately has been RabbitMQ based.
Yep.
What's the good thing about RabbitMQ? Like, why is that of all there's a lot of messaging options out there? Why are you kind of leaning towards RabbitMQ, or are you?
Yeah, I definitely am. It's right now. It's my personal favorite, personal choice for message queuing systems. But like you said, there are a lot of them out there. There's RabbitMQ, ActiveMQ, ZeroMQ, Azure Service Bus. Amazon has a simple queuing service. There's IBM, previously called WebsterMQ. I don't remember what it's called now. There's a lot of queuing systems out there. MSMQ. I like RabbitMQ for a number of different reasons. It is cross-platform. It's
Yeah.
written in Erlang, which is an interesting language in itself, a highly, highly, highly stable, extraordinarily robust and performant language, Erlang, built explicitly for performance to handle billions of things a second in financial industries. So
And
it is a
it's built on messaging, isn't it? Like the
yeah, yeah,
of Erlang
it
itself.
is. Erlang itself is built around messaging internally in the language, and so there's the cross-platform compatibility because you can install Erlang on just about any platform you can imagine: Windows, Linux, Mac, Unix systems, wherever you want to put it, pretty much. But there's also the cross-language compatibility, like you mentioned previously. It is very common to have a RabbitMQ system, a messaging-based architecture with RabbitMQ built out of more than one language. You might have Node.js for one part of it, and .NET for another, and Java for there, and PHP over here, and C++ over there. And all of these languages can communicate with each other by using JSON documents and RabbitMQ, because there are drivers and libraries available for all these different languages, and a phenomenal community of people around RabbitMQ that are going to be there to help you, to give you, answer questions and support and all that kind of stuff. And also, RabbitMQ is free. It's 100% open source. I think it's Mozilla public license, which is one of the most permissive licenses out there. It's like, here, do whatever you want. It's open. You can do anything, including modifying the thing yourself and whatever you feel like doing. It's a pretty amazing ecosystem that they have built around it at this point.
Awesome. Okay, so I guess I'm trying to think of like the scenario. Like, so I'm out there working on a project with my team, and maybe I'm using Node.js, or maybe whatever language I'm using, and then now I'm realizing that we're doing a lot of things in the web application where the user's waiting, or our systems are kind of coupled together. We feel like we need to implement a messaging pattern.
Or
some real robust.
Yeah, so or an even stronger signal is you might have a database table with a bunch of records in there that have a flag that say processed and unprocessed, and you have other processes that read from the same database and update the same table as the main process in order to know which ones have and have not been processed. I mean, that's kind of the poor man, sad man version of a queue, where you end up with some really awful situations by using a database as an integration layer, which is a really bad idea.
Okay. So that'll probably connect with a lot of people, because I've been there on several projects where we're like, okay, well, it's robust because it's ACID, because
it's the database, right? The database is always there.
Yeah. Okay. So in one of those situations, then maybe I would want to look into a message broker.
Right.
And then and then RabbitMQ, I guess, definitely is an option. So now you've put together a package on RabbitMQ, right? So if someone, maybe tell me a little bit about what you've got for someone, because I really think that people should be understanding messaging, and I think that sometimes like I said, we talked about RabbitMQ, but one thing I liked about RabbitMQ is that it's very like ground level, like you can get very bare bones, or you can build on top of it. And sometimes the default answer is still, for a lot of, I think, enterprise architects, is BizTalk, and BizTalk's like overkill most of the time. For messaging. So maybe if you could talk about what you've put together to help people to get into messaging and make this easier, because this is not an easy world to like wrap your head around. At least I don't think it
No,
is.
you're right. It's not. There's a lot of new terminology, a lot of new technology. It can be difficult to understand how the code is really working throughout the whole system at times because you're creating a very decoupled architecture. So the package I built is called RabbitMQ for developers, and you can find it at rabbitmq4devs.com. Either the number four or the word four in the middle, either way works there. Um, and what I've got is a series of 12 screencasts that will walk you through installation of RabbitMQ across Linux, Mac, and Windows, configuration of RabbitMQ so you can get it up and running and have it set up appropriately for your application to use it. And then it gets into a little bit of security to add permissions, and then straight into code after that, sending messages back and forth. It'll show you the basics of sending a message just through the management interface built into RabbitMQ, and then go into Node.js for the majority of the rest of the screencast and show you how to write code that uses the various messaging patterns and does various things with an Express.js-based web application at times in order to get work done. In addition to those screencasts, though, there's two ebooks. There's the RabbitMQ Patterns ebook, which is a collection of the most common and most useful messaging patterns, most of which come from the Enterprise Integration Patterns book, but it's distilled and boiled down into how do I use this with RabbitMQ? What's the point of this pattern?
Right.
What's it really going to do for me? And how do I apply it to RabbitMQ? And another one of the reasons that I love RabbitMQ so much is every time I go back to the EIP book to look for a new pattern, I find invariably that RabbitMQ has either already implemented the pattern for me or has facilitated the pattern so that it is ridiculously easy. It's just, oh, this little setting here and it's done.
Nice.
So it's really nice to have that. And that particular book is written in a way that is not specific to any language. It discusses high-level concepts so that you can apply this pattern to any language that you're using RabbitMQ with. Then there's the other ebook, which is RabbitMQ Layout, and that dives into the why of RabbitMQ's configuration, the different exchange types, how routing works and works with queues in order to get messages to the right place at the right time. And it takes a very unique approach to exploring why of RabbitMQ in that instead of being purely a technical reference, it's a storytelling guidance system that I put together. So you actually get into the head of another developer, looking through their eyes as they are building out software systems for whatever company they work for, and going through the decisions that they need to go through and determining, okay, how am I going to set up RabbitMQ to handle this situation? Oh, well, we tried this and it didn't work. What about this? Oh, well, this is why it worked. That's great. We'll do it this way. And there's like 6 or 8 different chapters that go through the story-based examples on building out RabbitMQ implementations and the why for each of these different situations.
Awesome. Okay. And then do you said you have interviews in there as well?
Yeah, I mentioned an interview earlier with Jimmy Bogard, and there's 6 interviews total, including the one with Jimmy. I have an interview with essentially experts in messaging and architecture from all around the world, including a developer formerly at PayPal, somebody over in Sweden that looks at a very large firm over there, Udi Dahan, who is the creator of N-Service Bus, one of the RabbitMQ core team members and community leaders, and then production issues and how to do real production RabbitMQ with a person that runs a RabbitMQ as a service platform called Cloud AMQP. So there's a lot of phenomenal information packed into these 6 interviews, which are roughly 30 minutes each, a little longer than 30 minutes each, for more than well over 6 hours of material. I'm sorry, not 6 hours, well over 3 hours of material across these 6 interviews.
Awesome. Okay. So, and you know, I mean, I guess I would say that someone wouldn't really need to be like, I mean, obviously if you're building an application in JavaScript, this is going to or in Node, this is going to be super easy for you to get started with RabbitMQ. Right. But I would assume that, you know, even if you're not using JavaScript, I mean, a lot of these patterns, everything is going to be pretty much this. I mean, the language doesn't really matter so much, right? Because RabbitMQ is cross-platform. So if you're using Java or C#, if you can grok JavaScript, you're probably going to follow along and get a lot of value out of this, right?
Yeah, very much so. And all of the patterns that I show in the screencasts, and the screencasts are the only things that are language specific, but all of the patterns that I show are typically built into the libraries that you would use in any other language.
Right.
And Service Bus and Mass Transit in the .NET world have all of these patterns baked in. So you'll be able to just take these patterns and apply them straight through those two service buses by looking at the document